Oh, are we live? Yes, I think we are. So, hello to, I guess it's part 20 now. Today we will finish off with the little commenting, so we'll be going over the project, and with any remaining time, we will, what we will do? I think we'll do the menus for the last tab in the options. So, let's start off where we left. So, this is the folder we skipped out on. I sorted out where should what go. So now we no longer have to worry about that. So let's open up the three, I guess, big classes in our game management. So, so the first we have our wave manager, I guess. So what this does is it spawns waves and handles what gets spawned. So first we have a buttons. So our first availability button is a image of the button that shows if the next wave can be triggered or not. And then sprites show whenever the object is active or inactive. What do we have here? Instance of the object to make it accessible, easier. And then this is what so we have two sets of lists here. First one is enemies in wave. Enemies in wave is how many enemies we are currently spawning. So how many enemies are currently being spawned. So every time an enemy gets spawned, he gets added to this list, but there will be a little bit more on it in a second. And this is all available waves that can spawn within the game session. So this is where we drag every single scriptable object with the wave in it. And this is our little check that allows us to set the wave on or off. So this is the path that the enemies travel by, and wave number is just a simple piece of text, a text that shows our current wave, like so. Now this is set to public because we need to be able to have enemies get the path. I think we also set the path at some point, but we'll get to that in a second. So here, setting up the instance of this class. Now in start, we default all wave values to 0. What do we have? Updates the number of current wave. Yeah, so this is run every time we change the wave number. We might change this to a dynamic number because I don't think I'll go with 100 waves because that's a lot of waves to go through. Control spawning of the enemies. Yeah, that's exactly what it does, but let's break this down a little bit. So first we set up the default values of the wave, like the button color, resetting the list. Now, one thing that I've added was the delay between spawn to differ in the wave system. That's because for boss waves, I don't want if I want to have more than one boss spawn, I don't want them to spawn one behind the other straight away because that would be too much for the game. So they need a delay of some sort. And finally, this is what handles our spawns. So what this does is it spawns every enemy from the single wave scriptable object, and object disables them and adds them to the list of enemies in wave. The reason why we do that is so that then we can enable enemies from the list of enemies and enable with a time interval in between for each enemy in the list. So just like it sounds, this then loops through every enemy in that list and enables them one by one with the delay. Now, something we will change is currently we are using game object, we instantiate, but we will be pulling instead later on. And that means that we will have to slightly modify how this works, or maybe even pull all of the waves ahead of time. But no, that would be too much. Anyway, and what do we have here? So starts the wave when the button clicks. So it adds to a wave, starts the wave, updates the text, make the enemy spawn. And this is for grabbing the path from our enemies. And that's our little wave manager. Now, another big class, the game manager. So handles all game related features such as the money, health, all generic UI. It's actually a very small class, surprisingly. What does tower availability? What does this do? So this updates the UI image that stores a reference to an object that allows the tower locking to update automatically. Like so. It's a big space here. There you go. So money is the player's available money to spend for towers and upgrades. Player's total health amount. Text. And then player's total money amount text. Now this is a text that appears when we lose the game. Yep. A value that sets to true when the game stops. Used for, what is this used for? Checking lose-win state of the game. And then player health variables. Now, these will be actually modified by the difficulty. But yeah, sets up default values and updates all startup UI elements. So this updates player health. So this is run every time an enemy goes through our the endpoint. We basically lose a health, game over. So displays and the game over text when health reaches 0 and sets the game as lost. So this allows the user to leave to main menu when the game is lost. And this is a temporary to be deleted on final build. That's for both of these, and then updates the money. Yep, update money. So basically, updates the text. Updates amount of money user position in the UI text, as well as updates the availability of towers, like so. I'm actually surprised by how small this class is. Usually when I call something game manager, they're bigger. So handles pausing of the game in the game scene. Panel that gets displayed when the game pauses. Actually, something that I want to add is the pause menu. So pause menu panel needs to have a panel that it has output transparency so the user can't stop the game to plan ahead. Now, why would I want this? Is to add a little bit of tension to the game. For checking if the game is paused. Used mainly for things that don't get affected by time.delta time, like invoke function. There we go. Sets of the instance. Sets up. Whoa. Set the default. What the hell? Set panels and pause state. What we could actually do here is instead of running this, just call resume on start, like so. Now, one thing that we did change originally from pause is the speed of the game is no longer, I believe, handled in here. Oh, no bots in chat. Yeah, there is nothing in chat today. But on that, handles returning to main menu. Want to check out the game, by the way? I don't think you've seen it in a while. Let's open these guys. Yep. Let me just do that. Okay, so let's see how the game's preset. Let's change money to what it should be. How many ways do you have? From 1 to 10. Yeah, that's fine. Let's try from 1 to 10. Actually, I've been working on a new tower, which doesn't have an image yet. So I won't be using that one for now. I think it's quite balanced. I figured out a cool strategy as well. There you go. I tested it from wave 1 to 15, and I'm currently making waves from 15 to 20 in my spare time. So I would say, yeah, I played it so much. I tried. Oh shit! I'm so gonna not do this. Come on, come on, come on! Ah! There we go. So the key here is to get the slow tower by wave 4 or 5, I believe. If you don't get that, you kind of chop your leg, and because you get the fast moving ones. Ooh, I think we should be okay. There we go. And now I'm gonna slow it down. Is that because I think this is the wave? So the freeze tower is really clutch for some reason. I mean, I know why. Oh, so it's wave 5 where we really need it. I think we should be fine now. Maybe upgrade that one. Would be nice to actually upgrade this one instead. Or maybe even that one. These guys should be fine with their damage. Come on. Yeah. let's upgrade that one. Which is the wave where they move really fast? I thought it would be wave 5. It is. It is. If I'm gonna die, I'll be sad. Oh no, I am so dead. God damn it! Quick, quick, quick! No, I think they'll be fine because they do a lot of damage. I let 3 through. Yeah, I failed the beginning. The beginning, I should have placed the tower slightly differently because I ended up spending money on an extra X tower, which was quite bad. And now I'm so doomed. Wait, I have a plan. Delete that. Put that here. No. Yeah. Go on. Hit the ones. What am I clicking? No, I forgot to change the target. God damn it. Closest. Hit what's closest to you. I am playing so bad at my own game. And there you go. Let's get the next wave going. This is the key tower. This tower, really good. The burn damage does wonders. If I actually didn't spend so much money on the towers early on, I probably would have been better off by now. God damn it, I have only 2 health left. Let's upgrade this straight away, and then go for the AoE tower next. So this tower is magical. Look at it. Boom. Okay, that was look at the damage. Oh, the AoE just piles through the enemies like crazy. Okay, I think we're good. This is what we were supposed to have from the start. This setup here. What wave are we now? Next wave is a boss wave. I think I'm gonna do this here. No, I'm not gonna use that for a boss. Not gonna upgrade you. I'll upgrade you though. You and you, and I think you, and we should be fine with the boss fight. We have 3 towers to slow, which should be enough damage. Oh, he's so tanky though. No, he's good. I think 3 slows are doing the job. Like, I just need to proc fire for as long as possible. 100 health. Yeah, they got him. Okay, boom, boom. I think I only loaded in 10 waves, right? Yeah. So the game's not going to work after that. There you go. Intense. So what do you mean so close? I won. How is that so close? I did the 10 waves. Okay, back to commenting. So tower selection is a class that handles this guy here. Where are we? Let's just zoom in on our canvas. It's these buttons here. Yep. So this image is a image attached to this object, handles the tower image display, like so. Now, what is this? The scriptable object that has all the tower stats and pricing. So this is how we know which tower it is meant to be, which price it has, and which tower we are going to spawn, etc. This is just the text. So the text that displays the price of the tower, which is right here. So when I press play, what do we have? We have all of the prices loaded properly from their scriptable objects, which can be found in here, like so. Where are we? So if I were to change the buyout cost to, let's just say, 22, that would instantly update here to that value. And then availability icon is the locking image that shows that the tower can't be purchased. So the locking mechanism doesn't have any functional use in terms of code, but what it does is it visually tells the player what he can and can't do. So right now I can buy all of these towers because I have 200 money, but if I put this tower, all of them become unavailable. And as a player, you can tell that you can't get it because of that sign. So that shows with user experience. Now, selecting tower is what happens when we click on the button. And what this does is it disables any other player interactions that we had. So if we had something selected, it will deselect that, etc. And then it will check our costs. So if we have more money than the tower is worth, or the same amount, we can then place the tower. So what it does is it enables the highlight instead of placing the tower, because at that point we haven't placed the tower yet, we are choosing. So it enables this little see-through highlight with the range of the tower, so we know where to place it, and we of course can disable it with a right click. Now, checking pricing, this is what checks the price and what sets the availability icon to true or false. So this gets called uh, by a different class, and what it does is it checks if the money matches that, and if not, it locks. The way we showed in the tower example, when I placed it, all of them became disabled, because there is a class that handles all of them, and then we'll loop through every single icon that we have, and we'll just close them if necessary. I believe that is attached in... Where would it be attached? It's a very good question. Well, it's somewhere in that piece of code. Oh, there we go. It's the tower availability, wherever this is. So what this does is it updates availability icon on every single placeable tower image, like so. And this stores the references to all available tower icons. And this loops through all of them, like I said. Now, slow motion is a brand new mechanic that was added, I believe, 2 parts ago. I think it was part 17 or 18 on the stream. And what this does is it allows us to slow time, basically. From what I remember, a lot of games like these have the ability to slow. And I wanted to replicate just that. Also, it gives you more time to think, and you can speed up the process of the game so you don't have to wait. So, controls the speed at which the enemies move and towers fire, like so. And aside from that, this is pretty well commented. So selected object, so it basically displays a circle around a selected tower or an enemy. It's basically just that. There is this circle around each enemy and tower. If you click on it, it becomes enabled, and that's all it does. The stores a UI element of a circle selection, like so. Sets the object to be disabled by default. On mouse click enables the button. On right mouse click or any other interaction disables the object, like so. Very simple class. Now this is where we get to a bigger one, so let's skip this one for now and do the area check. So area check is it's a very small class, but it's one of the most important classes in this entire project. So what this does is it checks if we can place a tower. Now, what this does is it has the radius of placement, which is how big of a gap between the two objects there has to be, and then a value that allows or doesn't allow new tower placement, like so. Now let's go here. So this is a function that we run when we want to check, and we run it in player interaction. So this checks for any colliders if there are any in our radius, returns false. Like so. So this just loops through. So what this does is it draws a think of it as drawing a collider. It draws a collider from the object, the object, which is the center point, and then the radius, which is how big the circle is going to be. So if we just open Paint real quick, if we think of this as our center of a object, then we draw our radius dead on in the middle, and that will be how big the radius is. And then if we find any object inside of it, no matter how close, it returns a false. But if there is nothing inside of the circle, it always returns true. And now if we move on to player interaction, if we just remember this for now, we will see how it works in actual use. So handles users left and right mouse clicks. Right. Selection highlight. So the tower outline when placing a tower. Selected already placed object like a tower or an enemy. These don't need to be serializable fields, so that will be removed later. Instances of the class. So it can be accessed here. Reference to the UI that displays all stats for towers and enemies. A circle of range that is used for displaying the current range of the tower to be placed. There we go. And now setting up the instance, assigning camera and resetting all the default UI elements. And finally, what does this do? Disabling docks. So it disables the docking UI element, as well as deselects selected object, such as enemy or a tower. Enables the visual of the tower that will be placed soon. Placed after selecting the tower icon. There we go. And then update handles player movements. So we call in these three functions here. So first one, tower placement, very simple. If our highlight is not null, so that means we already have a highlight selected, we draw a raycast, and then this raycast changes our highlight to either true or false by using our area check radius. So let's see how that works. If we go into play, we place the tower. Look, so right now it's blue, which means it's available. If we hover over to the path, it gets red. On the other paths, it gets red as well. If we place it here and we pick another tower, we see that we can't place it on top of another tower. There has to be a space in between. So this is this section here. Now, left mouse clicks. So left mouse clicks does the exact same thing. We draw up a raycast. We check if we can place it using the area check, because when we move our mouse around is one thing, but when we click, we need to make sure that after that click there is nothing blocking. And then we place it on the positions of our mouse. The only position that we change is the y-axis, because we always want it to be at the same level. And we of course subtract money, etc. Now, so yeah, places the selected tower. And what does this one do? This is for doing the selection. So selects a tower or on enemy that are already in the scene. So this basically, whilst in the stats panel. So this selects the enemy. It's very simple. We'll go back. So let's give this a play. Place a tower. So this is simple. I place a tower, I click on it, and now I can see its damage range, rate of fire, all of these guys. If we start a wave, click on an enemy, we'll see the health, name, and an icon. Now, so this disables the highlight and the range circle. There we go. And that's this done. So we went through quite a lot of classes. Well, all of the game management classes. Now, I believe these were done. These were done. These were done. Scriptables we went over. I believe it's user settings we went over. So let's do utilities. And then finally move on to towers, because that was the last major one that we didn't go over. So tooltips is a relatively new class. It basically displays the tooltips so we know what everything is. I haven't set up all of the tooltips yet, but as you see, it does work on some of them. So slow attacking tower with moderate damage, fast firing tower, etc. It's very simple. We have a game object, which is the panel, and a text component. And all we do is we have two functions, one for disabling, one for enabling. We handle this using something we've never used before, which is the event triggers. And then as you see here, we put in the text below. Pulling script is what we use to save some space. We will be using this later for towers as well as enemy spawns. Now what we have here, particle control. So this is controls particle effects. So checks if this is the parent object of the particle system. The reason why I check that is because some of our particles have more than one particle inside of them, and I only want to do invoke on the parent, not on a child. So what we do here is we set the time to 0, so we start at the beginning of a particle each time it is enabled, and then we invoke disabling of the particle if it's a parent particle. Cancels invoke not to trigger it again when particle gets enabled. This is to prevent, so think of it that way. We disable this particle, but our invoke was at 1 second already. So we enable it, and then after a second it disappears, but it should have been 2 instead. Disables the particle. Now, FPS counter is more of a feature for us just to see the FPS. There is nothing else besides from that. It's a nice way to test the performance aside from using the profiler. and we went over the camera. So now we're going to go into the bullets and the towers. Let's start off with the bullets because I believe those will be the smaller scripts, and then move on to the towers. So we're going to start off with the first bullet. So our very first default bullet. So how long it takes for the bullet to disappear after it spawns. Now this is used as a final solution if a bullet, so let's just say usually bullets disappear on contact with the enemy, but if they don't, then they will just disappear after 5 seconds anyway. Reference to the trail of the bullet. Some bullets have trails that can be seen just by looking at the towers from the previous demonstration, and then how long the trail lasts for, and how long the trail spreads to. So this basically is the length and how fast it disappears of the thing. Sets up default values when the object is enabled and starts the disappearing function. Disables all the values by resetting them. Now this is the reason why I do these is because the trails do funny things if you don't clear them out. So I used to actually have a problem in one of my projects where the trail would just do some weird things from time to time. So I just learned from that point to always just reset all of these values, and I never had that issue ever again. So here, this is what we set the bullet. So when the bullet spawns, we pass some variables across, which is the damage, the target, and how fast it should go. The update, well, in the update we call a function. The reason why we call that is because it's a function that we change, and I found it easier to use in a polymorphism using that way. So this handles the movement of the bullet. So this handles how the bullet moves. So in this example, the default bullet moves towards the target, so it's like a lock-on system. Here we have collision detection, and we handle it in an external class as well. So handles collision between bullet and a target, disables the bullet on contact and deals damage to the enemy. And this finally disables the bullet. Very simple. Now that we have this, let's have a look at some variations of the bullets. So here we have a bullet that does overtime damage. So this bullet does overtime damage, and what we have here, I don't believe this is necessary. No, it is. So the damage that the burn produces, I believe that damage of the burn should not be available. We are going to actually change that slightly later. So let's add that here. Scale burn based on base damage. And then the duration of the burn. Now, I need to have a quick break. So I'll be back. I'm going to go into the AFK scene and I'll be back shortly. Okay, I'm back. Okay, so what do we have here? Handles the bullet collision of the burn bullet. Now, so what do we do here is we create a new effect for the bullet. Um, this could actually be technically moved somewhere else. I guess it doesn't matter. Burn damage. So let's just do the change I wanted to talk about. So if we go into our damage, what we will do is we will create a temporary integer and we will call it temp damage. And that's going to be equal to damage. And then we'll just do temp damage. What's wrong? It's a float. And then we'll do temp damage is equal to temp damage divided by 3. The reason I'll divide it by 3 is because I believe the default damage for the burn tower is 15. So we'll just do 5, which is what was originally at, but this time it will actually scale with time. And we just replace it here, like so. Now, now let's go through the punch through bullet. So the reason why the punch through bullet had its own one is because unlike every other bullet, a punch through bullet is not get disabled when it collides. So punch through bullet collision does not disable the bullet upon collision. So that's actually something different between this and the other bullets. So handles the punch through bullet logic. Now let's go to the spike. So spike bullet is what the punch through bullet is basically based upon. So handles the class that creates spike bullets that fly in various directions in a straight line only. So here we have a start position of the bullet. Values when the bullet is enabled, also inheriting from base bullet, and then disabling the base bullet features, the custom, the polymorph is the way the bullet moves. Now what we have here, so this is our cannon bullet. Cannon bullet is probably the, I guess, the biggest change out of all the bullets. So handles the cannon bullet that moves in a parabola. So the biggest changes between the cannon bullet. Firstly, the cannon bullet uses a parabola as a traveling arc, which is different than most of the other bullets, because prior to this we had a bullet that flies in a straight line and a bullet that homes onto the target, so always go towards the target. But this one, it has a point, so it picks a point which is the enemy, but of course if the enemy moves, the point still stays the same and it fires the bullet in that place. And then it doesn't collide with the enemy, it collides with the ground. And only then, when it collides with the ground, it explodes and then it deals damage to the enemies. So what do we have here? Let's just do some comments. So how big the splash radius is of the cannon. There we go, like so. What we have here enables all the default bullet values as well as sets up for the parabol movement. Disables all the default bullet features. What do we have? So we set this the exact same way. The only difference is that our target is also our end position. And for our handle collision, so handles how the cannon bullet collides using the AoE. So what we have here, so we check if our collision target is not the enemy, which is true because we want it to be ground. And in this game, the only other thing we can collide against is the ground because nothing else has a box collider. Well, actually, the towers do, but the bullet would never travel towards the tower anyway. Maybe you could make it travel towards the tower. I actually don't know. This might be something worth adding. Check if the cannon tower can explode against another tower. Like this. Because if not, we'll just add another tank in here, which also checks if it's not a tower. And that's it. So what we have here is we calculate the AoE by getting every object like the same way we did with the area check. And then for every actual target that we find within the sphere, if it's an enemy, we grab the component of them, and then we do the damage calculation. We do the max damage calculation by doing a very simple maths equation, which does. So what we do is we take the damage, we multiply it by our relative damage, which is calculated by subtracting the explosion distance from our range, and then divided by range. There we go, and that will get us a damage based on how far the enemy is. So if it's dead on, it's going to be exactly what it's meant to be. If not, it's going to be less. And then, of course, we disable the bullet at the end. This is the entire script for, well, this is everything in Unity for Parabola, and this is the maths, the parabola function. So, yeah, I'm not going to go into it. It's a this is how in C# you can do the parabola formula. But basically, you need the starting point, the ending point. So let me show you. It's paint time, basically. So imagine that this is the ground. This is our starting position, and this is our desired position, which is the end position. And then start. Right. So we want it to go from here to here, right? But we want it to go in a parabola, right? So what we do is we give it a how high we want to go, right? So we want to go about here. So what the function does, it calculates the middle point, which is here, and that then draws us an arc like this. Well, more rounded, but that's the point. So we have our start position, we have our end position, we have how high it goes, and then we have time. So when our time is at 0.5, it's here. When it's at 1, it's here. When it's at 0, it's here. And of course, 0.25 would be here, 0.75 would be here, etc., etc. And that's basically, yeah, so this is the lerping part of it, and that's it. Disables the bullet. So here we have it slightly different because we have our particles, so we have to draw our particle upon collision, which we do, and then we disable the bullet. This is just draws gizmos to see the range of the bullet, used for testing only. So I'll show what this does. It's very simple. If I place a cannon tower and let's press play and stop the game as soon as the bullet spawns. There we go. Let's go into our cannon tower. We see two sets of gizmos. The blue gizmo is the radius of our explosion. So when it slams down, this is what it's going to cover. All of these guys will get hit. That's it. It's just purely for testing. What else do we have here? We have 5 more classes to go through, and that'll be it. Tomorrow we'll be back to programming again. The real question is, what out of the list to do we will program? What do we have here? Go away, go away. So stores all. Wait, why does the tower store debuffs? Ah, I know why. Because the power can be debuffed. I mean, debuffed. It's called a debuff, but it's actually just a buff. I should have named that class differently. Stores all buffs applied to the tower. So same way enemy can be debuffed with slow and fire, we can add buffs to the towers, as we have the range buff in the project right here. There's going to be a damage one later on as well, but for now it is what it is. Tower stats, of course, this is where we get all of our tower numbers from. This is where we get our layer. I need to remember to get rid of this later for our final build. Where are we? Now, this is purely for how fast how fast the tower rotates. This is just to provide that smooth rotation between the tower. Pulling of our bullets. The smoking animation that comes off from the gun. Muzzle. What do we have here? Nah. The tower stats for shooting. I'm gonna leave it as that. The level upgrade of the tower. The sound that will be played. The source object that the sound is played from. Used for setting up the mode in which we fire. And then, what do we have here? This sets up default tower values. Disables buff check function. Yeah, setting up. So this is how we set up the firing mode. So if you remember when the tower is placed, let's press play real quick. We place the tower, click on it, and then we can change between these 4 types, which is exactly what this does. And this gets called in here, and this allows us to target closest, furthest, lowest health, and highest health targets. This updates the stats. This is called every time we upgrade the tower or place it the first time around. Handles aiming, shooting, and firing per frame. This will be changed later because per frame is too often, in my opinion, for aiming and firing type. It shouldn't be so much. Maybe shooting, but not anything else. Find the nearest target. Yes, so this finds the nearest target, this finds the furthest target, this finds the enemies with lowest health, and this finds the enemies in lowest range. They're basically the same functions, but written slightly differently. So what this one does is it checks for distance like so. This is the reverse of the previous function. And this instead checks for health. And I guess I could have made them into a single, 2 functions, but then I would have to have added more if statements in between. So yeah. Now this handles the shooting logic. So shooting logic is quite a head full, I guess. It checks for if we have a target, then checks if the target is enabled, because having a target that is disabled is a thing. Because we don't want to destroy things, we want to disable them, although we're not pulling them just yet, so that will technically never matters anyway. Then what we do is this is the reload system. So we add a number to reach its rate of fire, then we fire a bullet, reset this to 0, and this entire process repeats. In the meanwhile, we of course have to make sure we have bullets, because if we don't have bullets, it can't fire. So this is more to prevent the game from crashing, although we should never trigger this really. We check for animations. So some towers will have animations, and this will play the animation. And then here we check for gunfire. I believe gunfire is a particle, yes. So this spawns the particle if there is a particle to be spawned. And this plays music if there is music to be played. And this spawns the bullet and sets it to be positioned by the muzzle. So here we have play sound, plays particle, and then plays animation. I do the if in because not all of them have animations, not all of them have sounds, and not all of them have particles. This sets animation to disabled. We do this so we don't get weird animation glitches. Plays the sound of the tower gun. This is just for playing sounds, and it also uses the volume that is in our save data manager. Adds a buff to our list of buffs. Debuff counter checks through the buffs to remove if necessary. Yeah. Like so, and that's that. So let's go through all the other towers now. Signal tower is slightly broken right now, so this will need fixing. So let's just do quick commenting. And what do we have here? So a tower that boosts range of nearby towers. Then this, I'm not going to comment it because I need to fix this. This doesn't work properly, so let's close it for now. Let's go into burn tower. So burn tower doesn't do anything. So handles buff tower, class responsible. So right now buff tower doesn't have anything special, which means it doesn't do anything. So it doesn't matter. This is actually, I thought it was going to have more features, but I just couldn't think of anything to do, so I just left it as this. So right now it does the exact same thing as a tower. There's no difference between this and a tower. But since I already changed the game object, I'm too lazy to replace that. Let's go into cannon tower. Cannon tower, again, same as the previous tower, so handles the cannon tower functionality, which is the exact same functionality as a basic tower. Whereas freezing tower is slightly different. Now, handles freezing tower functionalities. Because the freezing tower, first of all, there is no bullets for a freeze tower. Our freeze tower instead has a ray which draws between the tower and the enemy. So just as a line that connects between the tower and the enemy. Debuff generated by the tower. So what we do here is sets up the debuff for this tower. So since it's a freezing tower, it will have the debuff of type freeze, and here we set up some stats here. The reason why we set debuff damage to 0 is because we don't want to do damage over time when the target is frozen. and that's because our freeze tower does constant damage anyway. Also, we have fire damage to do damage, so I don't want to have two towers that do the exact same thing, because that would make a fire tower not be as good. Okay, so what we have here, public override, so handles how the freeze tower shoots. So we shoot by drawing a line between enemy and itself and doing constant damage over time while applying the debuff. And this is it. So what we have here, we set position 0 is us, 1 is our target position, and then we constantly do damage times time.delta time, and we keep applying the debuff, so our enemy is permanently slowed while he's affected by the tower. And now finally, the class that handles the functionality of the spike tower shoots bullets in various directions. So here again, a short one, we change how we shoot. So it changes how the tower shoots by storing multiple muzzle points and shooting in all of those points. Also aims by checking for range. The aim bit could be changed, but I think it's more convenient to have in a single function than two separate ones. Oh, I was changing classes while we were playing with the project. So I think that's it. We went over every single function. So that means it's finish. We finished with the commenting part. There's not going to be any more commenting streams. Our next big streams that are more dedicated to talking about the project and fixing bits here and there are going to be the profiler one, where we're going to try to fix performance. Well, at least make it a little bit better. And then, yeah, that'll be it. And then maybe some code fixing as well, but I presume I'll do most of the code fixing off stream, or try to put it together with the profiling section. So that'll be it for today.